Hello guys, welcome you all for this end-to-end session of AIML and DL. Okay, where you guys gonna learn everything that you guys need in order to become a successful data scientist. Hope you guys are enjoying. We are enjoying a lot. We are learning a lot each and every day. Hope the same thing for you guys. And one more thing before coming to the session, as always, please make sure you guys watched all the previous session videos so that you can have a better understanding of what we're gonna talk. Okay. And one more thing, guys, we have completed playing with data, entire thing. Okay, EDA, we have come across everything. The module of playing with data is completed, and then we have completed machine learning, everything, all the algorithms, the coding part, black box, everything we have completed. Now we have stepped into a new, I will say, next module that is called as deep learning, where we have completed one algorithm that is ANN. Today, like last two sessions, we have discussed about CNN black box. Today, we're gonna complete the coding part so that CNN will be over. Okay. And one more thing, guys, as mentioned, like we have 2000 plus quizzes which are on live in our YouTube channel. So please make sure that you guys go and attend the quizzes. It can be right or wrong, no problem. Okay, just go and have a feel of it, how it is, how much you guys can understand the things. Okay, and one more thing, like please make sure like you guys subscribe to our channel, because like every day we're gonna post a new video, right? So that if you subscribe and hit the notification icon, then you're not gonna miss any of our videos. Okay, so without wasting any time, let us jump into today's session. Today's session is all about the coding part of CNN. That's it. Okay, so convolutional neural network, I hope like I will give a gist, so please make sure the last two sessions is all about convolutional neural network theory part and black box. Please visit, revisit, and then just learn about it. Okay, if you guys doesn't understand, let me give a gist of it. CNN works for image, where it gonna apply the filter on top of the image. For example, consider this is an image, and it gonna how it gonna learn means simple. Okay, what it gonna do, it gonna create a filter. So consider this is an image, and it's gonna create one, two, three filters. Then one, two, three, totally six, three, and then one more thing, one, two, three. So totally nine filters in order to understand this as an image. Okay, so this is how CNN works. So guys, we have a dedicated session. Last two session is all about CNN and its black box. Please make sure you guys watch that video. Okay, so without wasting any time, let us jump into the coding part of CNN. Okay, first guys, we're gonna import the necessary libraries. I hope like you guys already know, whenever we start, we need to import some of the necessary libraries which is required for building anything, building model, loading the anything. Okay, so first thing we are using is NumPy, which is used to perform the mathematical operation. TensorFlow, using which we are loading all kind of layers that we need. TensorFlow.keras.models, we are using sequential model. Keras.labels, we are using convolution 2D, max pooling 2D, flatten layer, dense layer, and then dropout. Okay, then we are using keras.utils, we are using two categories where we're gonna convert the categorical value to the numerical one. We're gonna have a train test bit from sklearn, standard scalar from sklearn library, and then accuracy score from sklearn, and then we are using matplotlib for data visualization. Okay, perfect. I hope like you guys are able to understand. Now I'm going to use something called as a MNIST dataset, which I load from the TensorFlow.keras dataset MNIST load dataset. I'm going to put it to the variables. Here we are just directly putting it to training and testing sample, like x train, y train, x test, y test. That's it. Okay, I'm just loading it off. Guys, just see here. This is what the training set that we are having. Okay, x train of 0, 5 image. We are having a 5, like number 5's image. And for y train, we are having a label that is, it is saying it is a 5. Okay, similarly we are taking something else. Okay, the test image of 0, it is saying it is 7, and its label is 7. That's it. Okay, now we're gonna summarize our data. Okay, let's see, let us understand what is our data is all about. I'm just printing the training shape, xtrain.shape and ytrain.shape. Similarly for testing shapes, xtest.shape, ytest.shape, and I'm going to find how many unique number of classes that are present here. Okay, that is ytrain of unique classes. np.unique, it will explain what are the unique labels that we are having. Okay, now for training we are having nearly 60,000 images, and which is of we are saying it is 28 cross 28, and this is what the labels. Okay, if we are having 60,000 images as an input, which is training, this label is also going to be 60,000. Next, for testing we are having 10,000, and whose dimension is also 28 cross 28, and we're going to have something like 110 labels. Okay, and This is the number of classes that we are having, 10 classes. Guys, this is what the data set. We're gonna have the images of 0 to 9, that is 10 classes, and the model is gonna predict it. Okay, we're gonna have, this is a kind of handwritten digit. Okay, MNIST data set. We will be calling in short form. Okay, I hope like everything is clear till this point. We have just loaded our data. That's it. We have imported the necessary libraries and we have loaded our data. Let us move on to the next step. We're gonna pre-process our data. Okay, you guys can understand, right? Uh, this is black, okay, black and white. What we're gonna do means we're gonna convert to a threshold of 0 and 1. Okay, that is, we're gonna make it as black and white color. Okay, if it is a colored image, it's gonna have a 255. It's the maximum value that it's gonna have. Okay, now what I'm gonna do means I'm gonna make something like it to the normalize, and I'm gonna make it as the black and white image. So what I'm gonna do means I'm gonna take all the training data. I'm gonna reshape it -1 28 cross 28 comma 1 divided by 255. That means I'm just normalizing everything to only 0 and 1, that is black and white. Similarly, this x test divided by 255, that's it. Okay, now y train and y test. So y train, we are having 7 labels from 0 1 2 3 4 5 6 7 8 9, right? I'm just going for something like 2 categorical y train, 2 categorical y test, that's it. Okay, just understand what happens. Okay, when I just use this, okay, train of 0, x train of 0, you guys see here we are having the value, everything related to 0, right? Wherever there is a value, it's going to have numbers. Okay, that is, now the data is scaled up only 0 to 1 instead of colored image. Even though it is black and white, we can see it as a black and white, but like it's a kind of a color. But what we are going to do means we're going to divide by 255, that is a colored image value, so that we can convert that to a black and white, like colored image of 255 to 0 and 1 for black and white. That's it. So you guys see here we are having the value ranges from 0 to 1. Similarly here also 0 to 1, everything will be in the range of 0 to 1 because we have scaled up it by dividing the values by 255. Now moving on, you guys see here y train of 0. Here it is label encoded. That means the value of the above one is 0 1 2 3 4 5. So fifth position is 1, so we call it as, this image that we gonna get is 5. Okay, this is what the label encoding, guys. I hope like you guys can able to understand, right? Index start from 0, right? So 0 1 2 3 4 5, fifth position there is 1. That means the image that we are given is 1. That's it. Now I'm going to print the test value of 0, and similarly like we're going to have zeros and ones only, 0 to 1 value ranges. And then what is the y test of 0? That is 0 0 0, everything is 0. So let us understand from index. So 0 1 0 1 2 3 4 5 6 7. So this value is 7. Okay, seventh part, that is 1, so the value will be 7. Okay, now let us build our model, guys. Till this we have normalized the things, we have loaded our data set, MNSD data set, we have gone for extend and next test, and now we have standardized it, that is from 0 to 1 by dividing all the things to 0 to 5. Okay, and also we have converted the label. If it is 7, we have converted to the 0 0 0, everything is 0, instead of only the index value of 7 will be 1, like that we have converted. Okay, our input are in the range of 0 to 1, and our output is also in the range of 0 and 1 only. So wherever there is a value, it is just getting up to 1. That's it. Okay, now let's build our model. Let's build a CNN model, simple CNN model. I'm going to allow a sequential model. I'm going to pass CNN, that is convolution layer, 32 number of filters. The kernel size is 3 cross 3. I have said, right, this box, that is 3 cross 3. Activation function is redo. I hope like you guys already know. In order to like provide kind of a like non-linearity, we are using activation function, since image is not a linear thing, right? Input shape is 28 comma 28 comma 1. Where I get this? Just see here. I'm just going up, guys. Just see here. What is the shape of our input image? 28 cross 28. Okay, that's the reason here also you can see 28 cross 28. Okay, so that is the reason when I print the shape also, it has 16,000 input like testing training data, and then 10,000 testing data, but the shape is 28 cross 28. So that's the reason I have put the first layer as 28 cross 28. That's it. Okay, that is the reason I have put. Okay, 28 cross 28, and one is the value like channel. Okay, if it is 3, it's gonna be RGB. Okay, since it is 1, it is only black and white. That is whether it can be a black or white. Okay, single channel. Now max pooling, I hope like you guys already understand. If you guys understand doesn't understand, please make sure you guys watch previous session videos. Okay, pooling layer means if the output of a convolution layer is like 100 or 200 feature maps, this pooling layer tries to reduce it. Okay, I'm using a pooling size of 2 cross 2 same. Okay, the filter value. Then I'm again having something called as a convolution layer where we are having 64 kernel size of 33 cross 3, and then activation ReLU. Guys, you can ask why the input shape is not defined in all the layer. We should define the input shape only to the first layer. All other layer acts itself and it can determine by itself. Okay, next. Similarly, like max pooling layer, both the things I can see there is a two stacks of convolution layer, pooling layer, max pooling layer, convolution layer, max pooling layer. Now moving on, we are just flattening up because like image cannot we cannot find the result, right? We are just flattening up. If it is a 3 cross 3 image, they're gonna be 9 pixels, right? So each 9 pixel will be flattened and we're gonna pass it to the dense layer. Okay, you guys can see here that is the dense layer of 128. Activation function is ReLU. I'm using dropout layer. That means from this 128, I randomly, that is 50% of neurons, I will just leave it out. That is what this dropout layer. Dense of 10, activation equal to softmax. Guys, why I put 10? Because my output is 0 to 9, right? That is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10 output. So I'm just putting this dense layer as 10. That's it, guys. This is a simple architecture of how to create a CNN from scratch. Okay, now if I summarize, guys, just see here. I'm having convolution layer as first, pooling layer, convolution layer, pooling layer, flatten layer, and then we are having something called as a dense layer, dropout layer, final dense layer. That's it. So we are having nearly 2,25,000, not 3 4. Okay, so this much of parameters that this model need to train. Okay, I hope you guys are going for a depth-wise search. Okay, where I will just repeat the things again because like I hope like there are going to be only 3 different things we're going to study. Okay, first of all, we have imported our necessary libraries. We have moved on something like loading our dataset. We have pre-processed our dataset. We have built our model from scratch and we are just describing it. Okay, moving on, let us understand what is this, how to train this. Okay, simple. We have done for ANN, right? The same thing we'll do. Model.compile. Optimizer is Adam, non-linearity. What is the loss function? Categorical cost entropy. It is a kind of loss. So each and every time when the training is occurs, right? How much of loss? Okay, how much of accuracy we need to find each and every training. So now training epoch. Metrics is accuracy. Okay, what I'm going to do means I'm going to define a variable called as history equal to model.fit. Guys, what is fit? Training, right? Simple. Model.fit. What is my training data? X train, which is training input. Y train is the training output. Validation split 0.2. You guys already know, right? For training, we are having 16,000 data. From this, 20% is given to the validation. Epoch is 10. 10 times it's gonna learn the entire 60,000 data. Batch size of 64. It takes 64 images. 16,000 images are there, right? First, it will take 64. It will train. Next 64 train. Next 64 train. Like that, it will keep on. Okay, guys, just see here. This is a 10 epoch which is run, and you need to go for validation accuracy and validation loss. Loss it should reduce, right? 0.06, 0.04, 0.04, 0.04, 0.03, and it keeps on going down. Yeah, it's keep on doing. Okay, now the accuracy, validation accuracy, initially it is like 0.98, 0.98, 0. It is keep on staying, and then so finally it reaches 0.99. And these two things related to validation data, these two things related to training data. Okay, accuracy starts from 80 and gradually increases to 99. Loss starts from 50%, 0.55, and it reduces to 0.02%. That's great. Okay, that's it, guys. This is how training works, and this is how you need to infer the training. Okay, guys, I hope you guys are understanding. If you guys doesn't understand, please make sure you guys subscribe. Like, sorry, you guys just put the your any kind of under that the things that you guys doesn't understand in the comment section, we'll take up and we'll solve your doubts. Okay, and let us move on to the next one. Okay, now I'm going to plot the things simple. I'm going to use the matplotlib plot dot figure. The figure size is 12 cross 4. I'm going to have a subplot, so where 1 comma 2, okay, 1 row 2 columns. So this is the first one, 1 row 2 column. This is the second image. Okay, first image, second image. This is first image, this is second image. First of all, I'm going to have the training data from history.history accuracy, history.history validation score, so validation accuracy. So these two things, guys, this accuracy for training, this accuracy for validation. That's it. This is plotting it up. Similarly for the loss, this loss is for training and this loss is for validation. I'm just putting it, and finally we are just gonna see what is that output. Okay, see here, guys, the training accuracy starts from something like I hope like it is nearly 91 and it keeps on increasing to 99, whereas this validation starts from 98 and keeps on to 99. Similarly for a training, loss starts from 0. I think 10, I think so, and it's moved down to 0.00 something negligible value. For validation, it starts from 0.006, I think 0.06, and it keeps on moving, and it is somewhat greater than a training. Okay, we need to train some more epoch. Okay, so yeah, that's it, guys. These are the inference of how the model is trained. Okay, I hope like you guys are understanding and able to like come with me, right? Okay, so again, guys, if you guys doesn't able to understand any of the point, just ping in the comment section. We'll take up and we'll solve your doubts. Okay, now let's go for the prediction. Okay, what I'm going to do means I'm going to pass the test data next test to the model.predict, which is the trained model. I'm going to pass to ypred, and what I'm going to do means ypred of x-axis, I'm going to take the augmax. Okay, why? That's a major thing, right? Because we're gonna calculate. Okay, it gonna do a probability value for the tin value. Whichever the value is high, it gonna take that. Okay, that is what. So this is ypred of um, so this is ypred of class, which is predicted by our model. Okay, y test of class, we already have a one not credit code value, right? Whenever we're gonna have a value one, then that is a value. So that also I'm just doing augmax. So for example, 0, for example, 1, 0, all the 9 values are the values are 0. That means the value is 0. So that value is 1. So I'm getting the augmax. So we're gonna get into the x test of class. Okay, guys, I hope like this is clear, right? We are just predicting the result by using our model. Okay, um, this is the simplest way that we can do. Okay, now let us calculate the accuracy. I'm just going for accuracy score from the metrics which is available in the scalar, and moving on, we're gonna have two different things. Y test of class, which is the value present in the data set. Y pred of class, which is a value which is predicted by our model, right? Now, when I compare to these two things, I'm gonna have a one score, like accuracy score. Accuracy score into 100, I'm just cutting to a floating point of 0.2, that is 22 digit, and we are having nearly like test accuracy of 99.07%. So it's a like wow accuracy. Okay, the model which we have trained is like it works smoothly for the dataset that we are having. Okay, now let us discuss and understand how we can predict the value of a single sample. I'm just using the test data 0, reshaping it to minus 128 watt, because we have trained in the model in this way. This is sample. I'm going to pass to model.predict of sample, and then axis is equal to 1, so that it will take as a column, and augmax, whichever the value is high, the probability value of any 10 will be right. Whichever one is I'm going to take that, so that I'm just using np.max. I'm going to add it to the predicted class. Actual class is the value y test of zeros, because like the x test of 0 is an input, y test of 0 is its output, right? And we are just mapping it out. Now I'm just going to plot it. Okay, plot the image with the actual and predicted labels. Now I'm going to show the image. We're going to have something like x test of 0 reshaped to 28 cross 28, and it's going to be grayscale. Okay, C map is grayscale, means we're going to have a color map which is grayscale. Now the title is actual result, that is which is present in the data set. Predicted result is a value which is predicted by our model. That's it. Okay, now I'm just showing I'm just offing the axis, that is that we're going to be no x-axis and y-axis. I'm going to off it off, and then I'm going to show the image. Okay, just see it. It's a 7. Actually, what is the thing? 0, 1, 2, 3, 4, 5, 6, 7, right? 7. The predicted value is also 7, which is predicted by our model. This value is already present in our model. This is an image. Okay, guys, I hope like you guys are able to understand the end to end of what I have told. Okay, if you guys doesn't understand any of this, please make sure that you guys put in the comment section. We'll take up and we'll solve your doubts. Okay, I will just go a summary of it. Let us understand one more time, and we will wrap it up. I hope like I'm just explaining lots of things today. Just I will sum it up, and we will complete the session. Okay, let's move on. Okay, now let's have let me give me a minute. Sorry, second. Okay, now convolution CNN. Okay, convolution neural network CNN. We are just starting by importing some necessary libraries. We have loaded the MNST dataset. We are just going for some kind of a visualization and essence of getting what is in the data, and we are just doing some summarization. And we go for a pre-processing conversion of colored image to a grayscale. That is zeros and ones, not a grayscale, black and white. Okay. Then we have gone for something like creation of architecture. That is sorry. We have converted that label also to categorical value. Okay, 0 or 1. Now input also we have converted, output also we have converted, and we gone for building the CNN model where we have this stacking of convolution layer followed by like max pooling layer. We have ended up with the flatten and dense layer with dropout layer, and final dense layer should match the number of classes in the whose number of dense neurons should be matched with the number of classes that we are having. Since we are having 10 classes, we are having 10 here. Okay, now moving on, we are just summarized our model. Then we go for compilation, and then we have trained for 10 epochs. It works good, so that we are just plotting the loss and accuracy graph of both training and validation by using matplotlib. Then we have moved on to prediction, where we have used our predicted model, sorry, trained model for prediction, and then we have used our actual result. Our model is getting an accuracy of nearly like 99%. Okay, now moving on. So um, this step is simple. I hope like you guys know, right? Predict the result using training model. So we are just predicting the result. Okay, all the result of test data. Here we are just calculating accuracy using the predicted result. Okay. Finally, we are just predicting a single sample where we have just reshaped it into the form where we have trained our model. Then we gone for argmax. Then finally we are just printing it out. We are just displaying what is an image present and what is the actual result, what is a model predicted result. Okay, so hope you guys are able to understand. Okay, if you guys doesn't able to understand any of the step, any step, okay, please make sure you guys just put it in the comment box. We will take up and we will solve it. Okay, guys, I hope like it is like nearly half an hour. Okay, I hope. Okay, today I hope you guys are able to understand a very depth of what is CNN. Okay, all the concept from now is going to be this much thing. Okay, so be ready for that. We are here to explain everything in a simple manner. Okay, so yeah, that's all about today's session, guys. We have completed CNN coding part. Okay, last two sessions we have completed a theory and black box behind the CNN. This session we have completed everything related to the coding part of CNN. Okay, hope you guys have enjoyed. We have enjoyed a lot. Actually, I have enjoyed a lot. After a long time I'm just explaining code for nearly half an hour. Okay, I have explained like I have enjoyed a lot. Okay, so yeah, hope the same thing for you guys. Please make sure just go through this video 1 to 2 times, get a perfect understanding of it. If you guys just stuck anywhere, just ping in the comment section, we'll take up and we will solve your query. Okay, so that's all from my side, guys. Bye guys, take care. We will all meet in the next session. Bye guys.